So, as the final chapter for this e-learning lecture, I have now good graphs, bad graphs. So it's a sensitization, so it's a presentation of results, and I want you to look at it and to learn, okay, what is good style, what is bad style. I will present to you some of them within this course here right now, but you will also have a PDF document in the e-learning with good graphs, bad graphs, and you can scroll through it. So you will have on one slide and graph with the question, is this a good or a bad graph and why? And on the next slide, you find then the answer and the result. So take your time, look at the graphs, try to understand, okay, why is this a good graph? Why is this a bad graph? Also for you as a learning, because out in the wild, no one gives any information if this is a good graph or a bad graph, but I want you to learn how to interpret data visualization and how to interpret those graphs, and to learn also where to look at if someone wants to manipulate you with misleading graphs. Also two books which are quite nice, or one book here, a book recommendation is Calling Bullshit by Carl Bergström. There is an old version, a new version of it, so both are good, and if you want to read it, give it a read. So yeah, obviously it's quite cool because they also have a more profound introduction on the art of skepticism in a data-driven world, because all of us are working more with data today, even worse with all of those AI systems out there. And so we have to really look at if someone is trying to manipulate us and manipulate us with data, which seems to be like objective, but the data visualization, as I showed you, can be misleading. So for example, here we have now a bad graph because we have a misleading x-axis as the bar does not start at 0. So before we had graphs which had the numerical, the quantitative value in the y-axis, but this does not have to be the case. So you can also have the quantitative value in the x-axis, and if you then also don't start with 0, it's the same. Just the axes are different. We can have the same again with misleading x-axis. So here the scale changes, so that's also a problem because the data then looks quite different. So the scale and the bins might change, and also it's not starting with 0. So that's also quite a common way. So for example, they are using the logarithmic representation. So also keep in mind to really make clear, if you're using that type of representation of data, make it clear, write it down, yeah, make it visual so people understand, okay, you used a certain type of representation. This one here is very interesting graph, yeah, because it's very misleading. So take your time and look at it. So it's gun deaths in Florida, and if you look at it, you would say, okay, interesting. Over the last years, the numbers dropped, but then you look at the y-axis and you see, okay, it's inverted. It's starting with 0 at the top, and you're like, why are they doing it? Yeah, because there's no reason to do it. It's just that they want to show, hey, in Florida, gun deaths went down. Yeah, and that's not at all what you can see here. Yeah, you see in 2005, stand your ground law, when this was set up, so gun deaths increased. Yeah, and with this representation, you have the impression, okay, with this stand your ground law, gun deaths dropped. Yeah, so that's highly misleading, and in my opinion, also a manipulative graph. So now let's look at good graphs. So here you have the global metal use targets in line with climate goals, and you see different scenarios. You see a good figure title, yeah, you see a legend, you have all of the information on the different axes. You have also an indicator of the colors. It's also helping you with interpreting the data. And so in my opinion, that's an example of a good graph, which is condensing a lot of information. So you have a lot of information in this graph, but on the other side, it's also not, so it is understandable. So it's condensed, but still it's not overwhelming. If you look at this graph here, so this is, in my opinion, a good graph. Also, one might decide, okay, maybe it's still good, but there are some problems. Again, They have all of the information, they have figure title and so on. If you look at it, you see, okay, the top bar is always the average, I think, of all of the data in the graph. So this is nice on one side. On the other side, it's also like, okay, one could get the impression that that it's dropping, that the values are dropping. So they split it a little bit from the other data points. So then that way it's good. You could improve it by just choosing a different color. Yeah? So if you have, for example, with the brown bars, you have a darker brown or you have a lighter brown, then you would still differentiate a little bit more better, and that way it would be an even better graph. Yeah? So if you look at this one here, so you understand future emissions from low carbon power systems. It is somehow a little bit overwhelming because they are using quite some different colors, but the colors are linked to each other. Yeah, so they have an also nice representation. What might be better here, so they are indicating, okay, what is shown with the unit, but they don't have an axis title, so the y-axis title is on top of it, and also they are not really indicating what the x-axis is, which is like just the different categories. So again, it's a good graph in my opinion. Could be improved a little bit, but still it's a good graph. Yeah. So because it's very good differentiable which box plot is describing what. Also, this one here is a very condensed graph. So it's about the criticality of metals and metalloids. I like it a lot because with this color scheme, you can see, okay, 0 is blue, and then you go up to red, which is 0 is blue and a low criticality score, and 100 is high and red criticality score. And so you now can see with one view at the chart, okay, where are the hot topics? Where should I focus on? Yeah, which indicator is not that important, and you can also see within the column of blue indicators, okay, there's a red one. I have to look at it. Why is it red? Yeah, so I think it's a very good graph because and deciding on what you want to show. If you want to really show overall criticality results, this is not the right representation. Yeah, but this is a representation of all the indicators and showing the different criticality indicators, components, and axes. So therefore, it's very nice because it's a lot of data visualized in a very condensed way. But you cannot now say, okay, this and that has this and that score. But it's a different thing that you want to show with this graph here. So again, as I said before, the data and the data visualization has to fit to your storyline. So you have to change your storyline if your data is not giving you the storyline, and you have to adjust your data visualization in accordance to what you want to show. So you have to always think about, okay, what do I want to show? Why do I want to show it? And how can I show it? Not the opposite way.